Welcome to one of our near-surface disposal facility webinars. Today we are providing you a virtual tour of the waste characterization process we apply here at Canadian Nuclear Laboratories. You will see that the waste characterization process is much more than just taking a sample and sending it to the lab. But first, if you're not familiar with the Canadian Nuclear Laboratories, let me introduce you. Canadian Nuclear Laboratories, or CNL, and Atomic Energy of Canada, or ACL, have been instrumental in the development of Canada's nuclear industry. For over 70 years, nuclear technology has evolved to meet the needs of the world for clean, reliable energy and public health, safety and security. CNL is actively restoring and protecting Canada's environment by reducing and effectively managing ACL's nuclear liabilities at multiple sites across Canada. Today I'm here at Characterization Laboratories and I'm at Canada's first nuclear waste management facility. It was established in the mid-1940s and operated into the 1950s. As you can imagine, and as with many industries, the waste management practices at that time were not consistent with modern approaches to waste management today. Historically, we place waste in unlined trenches that has resulted in some localized environmental contamination. However, Canadian Nuclear Laboratories has a very robust and comprehensive environmental protection program. We collect environmental samples and routinely assess the risks to the environment and the public. Canadian Nuclear Laboratories has been safely storing waste within these licensed waste management areas for over 70 years. Our legacy waste management practices have not resulted in any unacceptable off-site impacts. However, CNL recognizes the right thing to do is to retrieve this legacy waste and place it in modern engineered facilities such as the NSDF to contain the hazards for an appropriate time frame and to isolate the contaminants from the environment. The near-surface disposal facility is the proposed disposal facility for CNL's low-level waste, such as some of the waste behind me, and will enable the environmental cleanup mission. Legacy waste currently in storage in areas such as the one behind me will be retrieved and characterized to ensure it is actually low-level waste prior to acceptance into the proposed near-surface disposal facility. In Canada, we have 4 classes or categories of radioactive waste: low-level waste, intermediate level waste, and high-level waste, which are generally the types of waste at the Chalk River site. There's also uranium mine and mill waste. We also produce clean waste, which we have a clearable waste process to disposition off-site following the regulatory requirements. Legacy waste can also be commingled, as in you can have multiple waste classes in the same waste package or storage facility. Since NSDF will only accept low-level waste, it is very important that CNL has a waste characterization process such that we can segregate the legacy waste and ensure that only low-level waste ends up into the NSDF. Canadian standards and regulatory guidance provide the requirements for classifying, minimizing, segregating, and characterizing the radioactive waste. And many of them are aligned with the best industry practices internationally. In the waste characterization process, there are really 4 main steps. First, we assess our waste stream using the process knowledge or scoping surveys. Then we identify the gaps of information you need to collect through your characterization process in order to properly characterize your waste and segregate it. For this step, we often develop a waste characterization plan, which tells us exactly how many samples and what characterization technique to employ. We then go out in the field and perform that waste characterization. As I mentioned, it may not be just taking samples, but there are many non-intrusive techniques such as gamma spectroscopy or scanning for radioactivity, which do not require collecting a sample. The last step is analyzing the data, and what we're trying to do is make sense of it. We're trying to establish what we call a waste fingerprint. This is simply a mapping of all the contaminants, constituents, or radionuclides that might be in that waste stream. Waste characterization at Canadian Nuclear Laboratories is also applicable to quality assurance and quality control processes. This is to ensure that we produce high quality data that provides us the confidence in understanding our waste. It is important to note that because our science and technology mission at Canadian Nuclear Laboratories has produced many different waste types or waste streams, we can end up having many different ways of how we characterize our waste. What is important to note is that we assess each waste stream individually. So without further ado, I invite you to sit back with your cup of coffee or beverage of choice and enjoy the virtual tour. First, we're going to head over to the sort and segregation operation in our waste management areas. Here, they recover legacy waste from our waste management areas and characterize it characterize it following modern practices to ensure we are segregating our low-level waste that is potentially eligible for the future NSDF. On the second part of your trip or tour, you'll head out to learn about one of our current decommissioning projects, which is removing a legacy building down at the Chalk River site. You'll hear from one of our characterization specialists how waste characterization processes are applied in practice from the planning phase of decommissioning through to the execution and waste generation. After the virtual tour, we'll see you back here for a question and answer period. Thank you and stay safe.
Hi, my name's Tarek Blimke. I'm the low-level section leader for Lowlevel Waste and NSDF. We have three functions in this area. First is waste storage, the second is the sort and seg facility, and the third is NSDF. For the sort and seg facility, we know that we have a lot of legacy waste. What this facility is doing, it's taking our legacy waste, we're doing initial gamma spec and characterization to that waste, putting it into the sort and seg facility where the workers are sorting through different waste streams, such as intermediate waste, low-level waste, mixed waste, haz waste. We're even finding clearable waste streams. We're separating those waste streams and putting them into different waste packages. Some of these waste streams will be going to NSDF. Through that process, though, there are multiple sampling campaigns, gamma spec results, gamma spec processes to define that it is meeting the NSDF WAC. Through there, we're storing that into disposal into the low-level yards, and eventually when the NSDF opens, that waste package and those waste streams will be acceptable into that disposal facility. Some of the different things that we found is we do have historical information on these waste packages. We are just working to a different standard now here at CNL. So with the different sampling, with the different analysis that we're doing on the waste streams themselves, we're working towards that NSDF WAC, and that's the higher standard of how we're verifying this waste is acceptable to that disposal. After the packages have been processed through the sort and seg facility, we are storing them in our outer areas in C-cans. We have over 800 C-cans in our parks right now that we know is destined for NSDF and is acceptable to go to that facility. The low-level team is very proud of what they've succeeded with so far. We take a lot of pride in sorting through the waste, making the waste acceptable for NSDF so we don't have to second handle it again, and just cutting down on the liability for the Ottawa Valley. We actually care about managing the waste, and we want to make sure that we're doing it right the first time.
Hi, my name is Chris Lariviere, Program Execution Manager with Facilities Decommissioning and Environmental Remediation at the Chalk River Laboratories. Our mission is to safely manage Canada's nuclear liability by removing redundant facilities on the site. Today, we've removed 106 different facilities across the site, generating over 15 million kilograms of waste. Most of it safely diverted to our on-site clean landfills. Today, I'm at Building 440, a facility that was constructed in 1945, primarily as a water treatment facility for NRX in its infancy, later on for the NRU facility. The team has safely executed the project to date. 65,000 labor hours have gone into the project from its kickoff to today's date, which is our demolition activities happening in behind me. Our team safely isolated all of the building services, removed hazards from within the facility, asbestos, perchlorate salts from within a fume hood and its associated ductwork, and several areas where contamination required remediation embedded within concrete and various areas throughout the facility. All of that characterization point data leads us to this point where we can safely manage the waste through demolition of the facility. Throughout our program life cycle here in Chalk River, we've generated over 15 million kilograms of waste. Much of it has been diverted to our clean landfills based on our characterization practices within the facilities, which is a good news story. However, we have generated close to 2.7 million kilograms of low-level waste that's been characterized, safely packaged, and awaits future disposal in the proposed NSDF. I'll now turn things over to one of our characterization specialists who will explain in greater detail our characterization process and how we get to this point where we can safely demolish one of these facilities.
Hi, my name is Gabrielle Pasotka, and I'm the Waste Characterization Specialist for Building 440. And my background is in environmental engineering. Now, the purpose of characterization is to understand how to segregate the waste in the building that is to be demolished. So we have clean waste, hazardous waste, active waste, and what have you. And characterization also helps us define what concentration of radionuclides we have in the waste, as well as their ratios, which is needed for disposing of the waste safely in the near-surface disposal facility. The characterization process is very robust, and it's based on international guidance, and it has many steps to make sure that we properly characterize the waste. The first step is understanding the historical background knowledge on the building. Understanding the systems in the building. So for instance, did this system connect to this system? Was this system contaminated? Were there spills on certain areas of the building? These are the kind of things that we look into to understand what happened in the past. The second stage of characterization is scoping. In this stage, we do non-intrusive checks of the building using techniques such as radiation protection checks that check for beta, gamma, and alpha. We also check for hazardous components such as lead that could be found in the paint in the building, as well as PCBs. The scoping gives us an idea of some of the contamination in the building and helps us develop the sampling plan, which is the next stage of the characterization process. In this stage, we collect physical samples of the concrete, brick, siding, metal piping, pretty much anything in the building. We collect these physical samples and we send them to the laboratory for radiological analysis as well as hazardous constituent analysis. In terms of determining the number of samples to take for different areas in the building, we look at the confidence level that we are interested in for that specific aspect, and this helps us to determine the number of samples that are required. An example of some of the samples we took here in Building 440 were from some of the basins that were contaminated, these clear well basins made of concrete. During scoping, we found that they were contaminated, and we took these about 6-inch concrete cores. We submitted these to the lab, and the lab cut the cores into little slices, and we were able to determine the depth of the contamination that the radionuclides had penetrated through the concrete. This information then feeds into the next stage, which is the remediation stage of the characterization process. In remediation, we, for instance, for the concrete slab, we shaved off the level of concrete that was considered contaminated. And once we shaved off that contaminated level, the next level we checked for beta, gamma, and alpha to make sure that it was indeed clean. Also in the remediation process, we take out some of the active piping and the active components in the building and safely package those separately. Next, we have the demolition phase, where we safely segregate the building. One part of the building was actually completely deemed active, so that whole section was turned into active waste into waste containers. And through demolition, they segregate the waste as it comes out. The most important stage of characterization, in my opinion, is the verification stage. So once we have all of the waste packaged into containers, we need to verify that the samples we took at the beginning and the scoping we did really matches the waste that was generated. For instance, we have packages of the clean metal that was generated. Once we have these packages of clean metal, we use gamma spectroscopy to verify that indeed these containers are clean. We also use gamma spectroscopy on active containers, and the purpose of this is to verify that the ratios between radionuclides that we determined in the samples that we took line up with the actual waste that is generated. So it's a good verification step that's performed at the end. So overall, the process from the historical knowledge gathering to the scoping, to the sampling, then to the remediation, the demolition, and finally the verification really shows the robustness of characterization and how it's really important that we're segregating this waste properly for eventual disposal at maybe the proposed NSDF, as well as segregating for clean waste, hazardous waste, and what have you.